All right, so enthalpy and really delta H, not really enthalpy itself, but we're going to use them as synonymous. So anytime I say enthalpy, we're really talking about delta H. But anyways, it's a state function. So what does that mean? This is like a physics terms. It basically means that we only care about the beginning and the end. Not how you get there. So for example, taking a look at our reaction coordinate diagrams, if we have delta H over here, and then we have our reaction going from left to right, if we have reactants over here, and then we have products over here, we can see and we can calculate our delta H as the difference from reactants to products, and that's our delta H. In this case, right, it's some positive value, it's an endothermic reaction. But how we get there from reactants to products can vary. So for example, maybe your reaction takes this sort of path. Maybe it takes something that looks like this. Maybe it does something that looks like this. And you'll learn about these in Chem 102 when you get to reaction coordinate diagrams. But the main point is when we're talking about enthalpy, we don't care. We don't care how you got there, right? They all took different paths, but they all have the same delta H. So delta H is a state function, right? Because it doesn't matter how you get there. The end result is that your delta H is the same value. So why is this important? Well, this is important because it allows us to predict delta H without knowing the reaction specifics. Right? We don't care about how it got there. All we care about is the beginning and the end point. And so we can take any path that we want, and our prediction will be equally valid as though it was the actual path the reaction took.